here at Hackersdan in Istanbul. Really excited to be here in Turkey. First time for me, flying all the way from Mexico, so it's kind of like a first. But I reckon for you, you've been all over the place.
We move around a bit. That's right.
And so for us, what brings us here is mainly all about chain key technology. And I reckon that's something that, came from your team and yourself leading that. So tell us a little bit about that. How did that technology came to be on mainnet? And more importantly, what's the best use cases for chain key? And let's take it from there.
Well, the history is that back in 2014, I was researching ways to build faster blockchains, and I was probably the first person using what's known as classical Byzantine fault-tolerant consensus math. Anyway, a lot of these protocols need to be driven by a random number. And even actually Bitcoin is driven by random numbers. You know that the proof of work that people produce is a random number that selects who gets to produce the next block. Anyway, we did that using threshold cryptography. So if you have a group of nodes, they create a signature, that's a random number, and then the next group of nodes signs the previous signature and they got a new random signature. You get a chain of random numbers. And what's cool about BLS threshold cryptography is that it doesn't matter which subset of the nodes combine their signature shares, the resultant threshold signature is always the same. It's always the same number. And this was very important anyway. So, way back, since way back, all of my blockchain designs were powered by random numbers created using BLS threshold cryptography. But over time, we use threshold cryptography for more and more purposes within the overall protocol. And today, the internet computer relies on this chain key, as we call it, chain key cryptography to scale. So, internally, the internet computer is composed of lots of individual subnet blockchains. And these subnet blockchains are transparent to the smart contracts, the canister smart contracts. But the more subnet blockchains there are, the more canister smart contracts you can host. And the reason the internet computer can just scale out by adding new subnet blockchains is that each subnet blockchain has its own chain key.
Yep.
It's a kind of threshold signature. And so it can sign transactions it's sending to other subnets, and it can sign the results of transactions it receives from other subnets. And actually the network, the internet computer network, has a master chain key, which is held by the network nervous system subnet. And it's a 96-byte number, right? And if you have this 96-byte number, you can verify the signature on any transaction coming back. And the reason it's possible to scale is that these subnets don't need to see each other's blocks. Once they've seen that the subnet has a chain key that's signed by this master chain key, they can validate the signatures on messages coming in, and that tells them that that's a valid message from the subnet. And when they send a function call, a transaction to another subnet, and the result comes back and it's signed by the other subnet, the transaction from the signature on the transaction tells them not only that the message hasn't been changed, but that the other subnet's working correctly.
Yeah.
So now all of these subnets can interact directly without having to see each other's blocks.
Yeah.
And that's the secret of scaling on the internet computer. And of course, it's also important for things like crypto sessions. We don't have a wallet model, we have a user session model. And within it, a user creates a session with a smart contract. And within that session, the user experience is creating transactions and verifying transaction results transparently. And that as well depends on this chain key system. And actually it's, the reason it's called chain key and not threshold cryptography is actually it's a whole enormous assembly of cryptographic protocols. And in order to do chain key, you need to be able to establish these things called key shares on the nodes. And for that, you need something called a non-interactive DKG, non-interactive distributed key generation protocol, which is a complex thing. I think we had the first in the world. We proved it was possible. But you also need to do things like rotate the key material.
Exactly.
To make sure that it's not possible for an adversary, an attacker, to steal bits of key material one by one from the nodes and eventually
get the whole thing.
Eventually get enough material to sign themselves. So what's happening is that key material is constantly being churned and recycled and recreated. And so the only way that you can make a signature yourself is to get a snapshot of a large part of the nodes in the subnet blockchain, which is almost impossible to do. So all of that together is chain key, and that's essential to how the internet computer network runs. But we realized at some point that we've got all of this infrastructure, and we could tweak it and adapt it so that now these subnet blockchains can create transactions on other blockchains.
Yes.
If you like, without a private key. So an internet computer smart contract can create an EA, an Ethereum account, a public key, for which there's no private key. Instead, the private key is the blockchain itself. And the blockchain can sign for that Ethereum public key. So now you can have a smart contract on the internet computer that can create an Ethereum account and can create Ethereum transactions.
Interact with the main chain.
Precisely. And we also, this is Ethereum integration, something in progress. The first thing we did was Bitcoin integration. Yes,
and we're really excited about that. In Latin America, for example, in El Salvador, which is legal tender, and when we first started working with the Internet Computer Protocol, we saw like the big potential for it, right? So tell us a little bit about ckBTC. I think you've already done an implementation in Lugano, and so definitely it's like first world use case, right? And people are actually using ckBTC.
Yeah, I mean, Lugano is very exciting, and there's more work going on there to integrate that and drive adoption. I mean, I don't know when you got into crypto, but Bitcoin's what brought me in.
But what brought us, most of us, to be honest, right?
Yeah, I mean, anyone who's been in crypto for a while probably got drawn in by Bitcoin. I actually saw a paper by a guy called Wei Dai in 1998. It was called B-Money. The reason was I was using a library called Crypto++. And the web page is still up there, and you can still see B-Money. And that was one of the antecedents of Bitcoin. But for various reasons, I was involved in other entrepreneurial ventures. And so I didn't buy Bitcoin in 2009, which is a great shame.
Well, like many of us.
I pivoted full-time into crypto at the end of 2013, and I spent most of 2013 trading Bitcoin. But, so it was a kind of first love. And internet computers have been used to create a Bitcoin twin. It's trustless, there's no bridge. It's just based on cryptography and math. And you can think of it as like a layer 2 for Bitcoin. And you can transfer Bitcoin with 1 second finality. And it's deterministic finality, so after a second you can be sure the transactions happened or not. And the fees are almost, I forget what they are, but they're tiny.
They're not Bitcoin transaction fees. So that's, for Latin America, that's really important, right? That it creates, it enables adoption. And this is, many people right now that are listening to us are struggling right now, right? So I want to hold Bitcoin and I want to pay for something. Of course, you're using Sats, right, or Satoshis. That's what's being used right now in El Salvador. But it is a steep learning curve for many folks, right? Like retailers, for them to accept Bitcoin, they need to be comfortable. No, I'm not going to send you Bitcoin. I'm going to send you Satoshis, right? And so it's all of these things that I believe ckBTC enables, right? It enables fast finality, like you said. The most important, the secure the security of it, that's something that's really, maybe for the end user, they don't care. But for builders that are building on top, exactly, it is one of the main issues that we found in crypto, right?
Yeah, and on the internet computer, you can power smart contracts, or power a DeFi system, or power a social fi system using Bitcoin. And smart contracts are an amazing new kind of software. And one of their powers is they're unstoppable. You can make them autonomous. They're tamper-proof. You don't need a firewall.
And verifiable, which is very important, right?
Yeah, the cryptography is verifying it. There's no backdoor.
Exactly.
Doing something strange. But if you're processing Bitcoin with that kind of autonomy, then all of a sudden the Bitcoin loses its value because it's been hacked and it's really wrapped Bitcoin on a bridge. That's bad because the nature of smart contracts is they assume that doesn't happen.
Exactly.
And so it's very important, I think, when creating forms of Bitcoin that can be transferred more quickly and at lower cost, that they don't depend on centralization. They don't depend on a centralized bridge or something like that. And so the internet computer achieves that. It also makes Bitcoin available for people building these different kinds of Web3 services. And it's possible to create user experiences that enable adoption to occur in places like El Salvador. It's immensely exciting. I mean, one of the important points for those listening about Bitcoin is about ckBTC is it's not like a separate system. You send Bitcoin to a ckBTC address. You've got ckBTC, but you can send kkBTC directly to a Bitcoin address.
Exactly.
You don't have to go through a bridge or anything.
And I think that sometimes people miss that, right? People think, ckBTC, well, that's kind of like Lightning. I'm like, okay, let's just go 2 steps back, right? So it's not a channel. There's no centralized point of failure. When you're using Lightning, yes, you are basically trusting who built that bridge, right? That channel, sorry. And so I think that's one of the best things about ckBTC. And so the other stuff that, of course, we're really excited right now that we're at Devconnect as well. And I'm really grateful for Definity for sending us Diego Prats over to Ethereum Mexico and talk about ckETH and about the new wallet, but Bitfinity as well. So I think, can you talk a little bit about where is the roadmap heading in regards to ckETH? How's that's gonna look like? Where do you see the low-hanging fruit for builders as well, right? For that, because we're talking to them, right? And more importantly, we want more builders to build on top of IC. And so some use cases or some tips and tricks there.
So our vision is really, complete integration with Ethereum. So, the Bitcoin integration involves internet computer nodes talking to Bitcoin nodes and cryptography. That's it. And actually, there's a smart contract on the internet computer that keeps track of the UTXO set because Bitcoin's got a special model. You might imagine that the integration with Ethereum is easier because it doesn't have UTXOs. Actually, it's harder. It's more challenging, and there's a bunch of reasons for that. One of them is that Ethereum oftentimes tends to be more centralized. So, if you want to query Ethereum events and things like that, you're typically going to talk to Infura and Alchemy.
Exactly.
Whereas internet computer really needs to be able to speak to independent Ethereum nodes and more of them, so that it can get a high level of security. And then it turns out the standard Bitcoin clients, the node software doesn't reveal all of the information that you want. So anyway, there's quite a few things like that, including the gas model, that make the integration complicated. Having said that, progressively we're getting there. Recently we released this thing called the Oizy wallet, which is more of a demo, which is a wallet in a web browser. Yep. Not a Chrome extension, a web page that's a wallet.
Yeah. People were flipping out with when Diego was showing it at ETH Mexico. So it was like,
how's this possible kind of thing, right?
Yeah.
And this, because normally, if you're on a phone, for example, and you want to use Uniswap, you open the MetaMask app, and then you open a sub browser in the MetaMask app.
Exactly.
And it's all a bit clunky and weird and frustrating and what's going on.
And make sure to copy in a safe place the seed phrase, right?
Yeah,
if your onboarding is a mess.
That's right. You've got this seed phrase, and if somebody steals your seed phrase,
you're done.
Yeah, and actually that seed phrase or the key is typically live inside the browser extension.
Exactly.
I mean, it's not safe at all.
Exactly.
So with this Oisy wallet, it's an internet computer smart contract that creates the user experience, and your Ethereum account now doesn't have a private key.
Yeah.
It's a chain key private key, and you authenticate yourself to the Oisy wallet using internet identity, which is typically your fingerprint or whatever,
your face or
and now you tell the smart contract to execute, to create these transactions. So currently, Oisy can, show your, show you, your Ethereum assets at the address, ETH, ERC20 tokens, and so on. And using Wallet Connect, it works with Uniswap or whatever other DeFi app you want to use, and it's all inside the browser. So the lovely thing about that is all centralization is removed. There's no centralization left, other than the domain name itself.
Yeah, but that's normal.
We're working. We are actually. Don't worry. Definity is working on that. But apart from the domain name, which is I'll bet noir. Damn, this system in the ICANN has the root.
It's still a censorship point, right?
It is.
So
it's designed that way. It's very much designed to allow America to take control of the internet, of course. So anyway, aside from this, it's fully decentralized. So it's more secure. There's no seed phrases floating around that can get stolen, and the user experience is better.
Yeah.
You can open your phone.
Yes.
You can open Oisy in one tab. You can open Uniswap in another. You can link them, and there's not an app in sight, so there's nothing that has to be downloaded from the App Store.
Exactly.
That can be censored.
Yeah, exactly.
Or indeed.
Or used in a malicious way as well.
Used in a malicious way, and it's the same too with even on the desktop. You don't have to download a Chrome extension. So we're pleased with that, and we're going to we've decided we're going to do some more development work on Oisy. It was really produced as a sample app actually. But we're going to push it further, show people how to add very sophisticated kind of multi-auth or multi-factor authentication with complex rules and things like that, as an alternative to something like Gnosis Safe Wallet.
Yep.
And maybe even perhaps list some other kinds of asset in there too. And there's also now a ICP ERC20. It's not in production yet, but well, the step one, right? Step one is that all of the internet computer tokens like chat and hot and ICP and all these internet computer tokens, they will exist in ERC20 form on Ethereum.
Yep.
And ETH and ERC20 tokens on Ethereum will have chain key equivalents on the internet computer. That's step one. And it'll, of course, just like with Bitcoin, be very easy to go back and forth. There's no real bridge or obstacle. Step two is we'll have bidirectional calling for smart contracts. So there'll be a way for Ethereum smart contracts to call into an internet computer canister smart contract, and vice versa. And that means that Ethereum projects will be able to fully decentralize very, very easily within a very sort of rich platform. It'll be possible for an Ethereum DeFi app, if it so wishes, to store gigabytes of user data on chain.
Yeah.
Because a single canister smart contract on the internet computer can have up to 96 gigabytes of memory pages.
Wow.
So now all of that kind of functionality.
It's now available for Ethereum developers.
Exactly, available for Ethereum developers. Internet computer smart contracts can process HTTP and create a user experience. As you know, they run in parallel and they scale very well and they're very low cost. So now within that Ethereum environment, the systems that exist there can either, if they're already fully on chain, just become much richer by extending onto the internet computer, or if they're relying on centralized traditional technology like cloud services, Amazon Web Services, which presents reliability and security risks, and of course means that users of the service can never really be sure what's going on. It's not transparent. Developers have backdoor keys, all that stuff. That'll be another big opportunity for development, Ethereum developers. And then there's a step 3 actually, and the step 3 isn't really so important, but it's like a replacement for OISI. It's called Duality, and this will be really cool because when you have Ethereum assets like ETH or ERC20 in your Duality wallet, which is on the internet computer, fully decentralized, no Chrome extension, no app. When you put Ethereum assets into that wallet, they'll then be simultaneously both on Ethereum and on the internet computer. So it won't be necessary to take your ETH and then send it to a chain key ETH address, right? There won't be any kind of. There won't be these two different forms. Each Ethereum asset will be simultaneously in 2 different forms.
Okay.
So, and you don't need to do anything special. If you go Duality wallet, you just, send your Ethereum assets there. You've automatically got chain key assets. And the reason that's possible is the Duality wallet, of course, is signing the Ethereum transactions. And so it can keep track of what your real balance is. So, I've got a Duality wallet, you send me 20 ETH. Okay. Actually, my wallet now has 20 ETH and 20 chain key ETH at the same time.
Yeah.
Right? But I can't use the chain key ETH for 12 minutes because there's a Ethereum finality.
There's.
After 12 minutes, I can send, Ricardo over there 5 chain key ETH to his chain key address. It'll appear in 1 second. Tiny fees. Of course, just the same as with chain key Bitcoin, like Ricardo can send an ETH back to you, and because you've got just a standard EA account, it'll go directly. There's no delay. Nothing special needs to be done. But there'll be a fee involved.
Yeah, of course. Somebody has to pay for the party.
Yes, exactly. So, but the cool thing is that the Duality wallet behind the scenes is able to keep track of all these things. So you as a user don't need to think about it. You've just got an Ethereum wallet, and now you've also got these same assets in chain key form. So if you send those assets to somebody who's got a chain key enabled wallet, the transfer takes 1 second, the fees are negligible, but you can also just send it to someone with standard EA account.
Yeah.
It still works. I mean, finality is a bit later.
And,
you have to pay.
We have the fees.
Yeah, and it's all completely, again, fully compatible with all Ethereum DeFi. Don't need to do anything special. So, I'm kind of looking forward to that.
We are also looking forward to that, right? And I think one important aspect here is that IC is going to enable the moat about onboarding 1 billion users, because that's not going to happen with the current state that ETH is at, right? They rely on L2s, and you have the bridges, and you have all this sort of hoops that a normal person is not going to go through, and nobody in Latin America is going to pay a $5 per transaction gas fee. It's not going to happen.
That's right. It's really for DeFi transactions.
Exactly.
So I think that's where the internet computer is going to add so much power to Ethereum. And the Internet Computer Project set out really to create a future version of Ethereum, but in actual fact, it's not a future version of Ethereum. It's something completely different.
Exactly.
And that's why it became a separate project. But it's designed to work on Ethereum.
Nice.
And one of the reasons why we invested so much time and energy into chain key crypto and making chain key crypto work with other chains is to enable this kind of world computer vision where everything's built end to end on blockchain, and different blockchains can communicate directly without bridges. And it's not just about communication, it's about integration, really, like seamless integration. Like this idea that you're an Ethereum developer, You like your synchronous environment because it's better for DeFi, but now, for whatever reason, you need to create a user account, and that user wants to store all this data in that account. That's fine. Just call into an internet computer, canister smart contract, and store that data there. Oh, you want to spin up a user experience? Well, you can't do that in Solidity. But just call into internet computer, canister smart contract, and have it produce the user experience. So even soon, there's some basic large language models, AI models running on the internet computer. We're leaning into that, and there's work underway to create a new kind of node spec for the network, because the internet computer runs on dedicated hardware. And currently, nodes are just very much optimized with respect to running these canister smart contracts. But there's a new node spec coming, which is more optimized for running AI models and smart contracts, among other things. So again, your Ethereum smart contract, call into an AI smart contract.
You enable that for Ethereum developers, right? Yeah. So at the end of the day, we're really excited what the Definity team is building, what you are leading, and more importantly for us is where is the next bounce of the ball, right? AI will be enabled. I think there's not a question in anyone's mind around that. So anyhow, Dom, thank you very much for your time. Really appreciate you. And enjoy Istanbul. There you go.
There you go.